Hey folks, today we are going to be covering section 1.3, which is actually the last section in chapter 1 of Shape Up. So the next time we have class, we are going to review, and the following class we are going to have a quiz. So enjoy the lesson. This is actually like one of my favorite lessons coming from a math teacher, but I hope you have fun. Okay, so section 1.3 is titled, Oh, the Things You Can Do with the Triangle Sum Theorem, or as I like to call it, OTTYCDWTTST. Just kidding. Today's date is 4/10/20, and we're going to be talking today about some things that we can do with triangles, but we're mainly going to be talking about polygons. So shapes with 3 or more sides, straight sides. We're going to be talking about the angles inside of these polygons, and these are called interior angles. So just keep that in mind as we're talking about what we're doing today. So let's take a look at this table. We have some types of polygons on the left here, and we have their number of sides in the middle and the sum of the angle measures on the right. So the sum of the angle measures in a triangle is 180 degrees. Now, if we were in person, I would have you actually draw a quadrilateral of your choosing, and I'd have you measure the angles using a protractor and add them up. But since we're not in class together, I'm just going to tell you that the sum of the angle measures in a quadrilateral is 360 degrees. Let's add a few more polygons to this. So we know we can add a pentagon that has 5 sides. We can add a hexagon, and maybe we will also add a heptagon, and heptagons have 7 sides. So we have 5, 6, 7, and I'm just going to tell you that the sum of the angle measures in a pentagon is 540 degrees. In a hexagon, the sum is 720 degrees, and a heptagon's sum of the angle measures is 900 degrees. Let's look at a table that's kind of similar to this. But before we do that, I want you to take a look and see if you find a pattern between the sums of the angle measures here. What are you noticing? Take a minute, see if you can notice a pattern. So maybe you noticed that the sum of the angle measures in a triangle is 1 times 180. And in a quadrilateral, it's 2 times 180, that's 360. And a pentagon is 3 times 180, and so on. This is 4, and a heptagon is 5. Interesting. There are other patterns you could have noticed too, but this is one that's going to be particularly useful to us today. So let's take a look at this table. So again, we have a triangle, quadrilateral, pentagon, hexagon, and then we move on to some other shapes here. And they've drawn us a picture in this third column, number of triangles. So in a triangle, obviously there's only one triangle. And the sum of the measures of the angles is 180 degrees. But in a quadrilateral, if you split up this figure into as many triangles as you can, you find that you have 2 triangles. So I take 2 times the measure of the interior angles in a triangle to get 360. In a pentagon, I can count 1, 2, 3 triangles and get 3 times 180, which will give me 540. So let's fill out this next one together. A hexagon has 6 sides and looks like this. See if I can do this well. Something like that. And let's find the number of triangles in it. So you can pick any vertex here. I'm going to pick this one over here. And I'm going to draw lines to each of the corners here, each of the vertices. And I find that I have 1, 2, 3, 4 triangles. So that's 4 times 180, which is 720, like we found before. I want you to fill out the rest of this table on your own and get as far as you can go. So your table should look something like this. An octagon's sum of all of the interior angles is 1080, and the sum of the interior angles of a decagon, which has 10 sides, is 1,440. But when you get down to this one that says polygon of n sides, we don't really know how to draw that. We don't know how many sides we have. So all we can do is kind of come up with a formula or an equation to express the sum of the measures of the angles. So let's take a look here, but we're not really sure what we can do right now. But maybe let's take a look at the number of sides and this number over here, this multiplier that we've been multiplying 180 by. So in a triangle, it's 3 sides, 1 is our multiplier. In a quadrilateral, 4 sides, 2 is our multiplier. Pentagon 5, multiplier 3. Are you noticing a pattern? That multiplier is always 2 fewer than the number of sides. So if our number of sides is n, our multiplier is going to be n minus 2. So we're going to multiply n minus 2 by 180. And that's going to give us the sum of the measures of the angles. So to reiterate, the formula to find the sum of the interior angles of any polygon with n sides, that's n number of sides, is going to be 180 times n minus 2. So let's say you have a polygon with 12 sides. That means n is 12, and I would just plug 12 in to my formula right here. So this is going to be really useful to us. The last bit I want to go over is something that we call regular polygons. So regular polygons are basically like, I kind of think of them as like perfect polygons. Like if you have a triangle, the most pleasing triangle to look at, to me, would be the equilateral triangle. Equal angles, equal sides. And let's say the most pleasing quadrilateral would be a square. Again, equal angles, equal sides. So a regular polygon is basically a polygon with equal angles and equal sides. So let's say I asked you to find the measures of each of the angles in a regular pentagon. So I'll say that again. I want a regular pentagon, meaning I have to have this kind of perfect pentagon, which is not going to be perfect in my drawing, but we're going to try. Good enough. So each side is equivalent to another. Every angle is the same. And I want to find what that measure of the angle is. I want to find that measure of the angle. So I can find the total measure of the angles. I can use that nice formula, 180 times n minus 2, to figure it out. So that's going to be 180 times 5 minus 2, and that's going to give me 540. So I know that all of the angles add up to 540, but I just want one of them. I just want to see, like, what is that measure? So I'm going to take the number of angles, 1, 2, 3, 4, 5, and I'm going to take my total and divide it by 5. And I'm going to find that each angle measure is 108 degrees. It's always good to do like a little self-check and make sure, like, does this look like it's about 108 degrees? Well, let's think. A 90-degree angle looks like this. So 108 degrees is probably going to be a little bit bigger. So yeah, I would say each of these angles looks roughly to be 108 degrees. This brings us to the end of our lesson. Thank you for tuning in. Go ahead and flip back to that Google Doc and check the assignment for today. I will be available to answer questions during the rest of the hour as well as office hours.